Hello everyone, my name is Michael. So today I'm going to do a lab demo on how to access and analyzing data by using Amazon S3. Here is the overview and objective of this lab demo. You will learn how to upload, encrypt, compress, and secure data as a .csv file in Amazon Simple Storage Service Amazon S3. Then by using the S3 select feature, you will use SQL statement to query data in Amazon S3 without needing to set up a database. After completing this lab, you should be able to do the following. Create an AWS CloudFormation template and deploy it as a stack to create an S3 bucket. Load data into an S3 bucket. Use S3 select to query a .csv file that is stored in an S3 bucket. Modify the encryption properties and storage type for an S3 object. Upload a compressed version of a dataset to Amazon S3. Review an AWS Identity and Access Management IAM policy that is used by team members to access the data. Test a team member's restricted access to the data by using the AWS Command Line Interface, AWS CLI. The duration of this lab is about an hour, so let's go to the scenario of this lab. In this demo, you're going to assume the role of a member of the data science team. The team includes the following members. Sophia is the team manager. Palos is going to focus on the collecting data, hosting the data, and building the infrastructure to support the data pipeline. Mary is going to focus on analyzing data and getting insight from it by using data analytics and machine learning (ML) tools. You will build a proof of concept to use Amazon S3 to accomplish some of the team's data analytic tasks. You are quite familiar with Amazon S3 from your previous work in the AWS cloud. One common task that the team does is use SQL queries on large compressed and encrypted .csv data files to understand the data. Currently, the team moves the .csv files to a SQL database where they can then query the data. The security team is responsible for managing backup and login access control for the files, and the team has manual procedures and rules in place to manage the data's life cycle. These tasks are well documented and the team is familiar with them, but the tasks are time consuming and prone to errors. One of your goals is to reduce the time that is needed to analyze this data. If you want to experiment with the S3 select feature, which you can use to perform SQL queries directly on .csv files are stored in an S3 bucket, you will use a customer contact information dataset in your POC. To learn more about the Amazon S3, you can go into the Amazon documentation and read more about the simple storage service that Amazon offers. So we're going to start this lab. So the environment will contain the resources. So in the below diagram. So for this lab environment, the original data source is the S3 bucket that exists in another AWS account. Here we have the AWS account 1. We have the IAM policy for the data scientist. And this is our bucket. Our bucket's name is ADE S3 lab bucket. This is on the AWS account 2. That's is our course bucket with the data set. So the lab environment is created with a CloudFormation template that is deployed when you launch the lab in Vocarium. The deployed CloudFormation stack creates an S3 bucket named ADE S3 lab bucket and an IAM policy named policies for data scientists. So here's some tips to review the CloudFormation template that built this environment. Navigate to the CloudFormation console in the navigation pane. Choose stacks. So by the end of the lab, you will have created the additional architecture. So in the following diagram, the table after the diagram provides a detailed explanation for the of the architecture and the task that you will complete while working through this lab. So here is the architecture, and we have the AWS Cloud One right here with our IAM policies. So first things first, what we'll do is we're going to create the buckets right here. Create a bucket. So we're going to create a CloudFormation template to create a bucket named ADE My Bucket, which is this step right here. And next, we're going to learn how to use the AWS S3 list bucket command to interact with an S3 bucket. Then you will use AWS CloudFormation delete stack command to delete the stack and the bucket, which is this step right here. List the bucket, delete the stack, and delete the bucket. Next, we're going to retrieve the original dataset by using the wget command. Then you will use the AWS S3cp command to copy the dataset to an S3 bucket named ADE S3 lab bucket. Which is the step right here, so on the diagram. Next, you're going to use the S3 select feature to query the dataset as a file store in the Amazon S3. You will build these queries as a SQL statement, which is right here. Select S3 select query. Then you will encrypt the data set S3 object file lab1.csv by using Amazon S3 managed key SSE S3 and modify its storage type. This is this step right here inside the ADE S3 lab bucket. We going to encrypt. We have encrypted lab1.csv. Next, we're going to compress an S3 object file lab1.csv.gz, then compare the size of the gzip and zip file. Step 6 right here, compress lab1.csv.gz. Then you will reveal the IAM policy, name policy for data scientists. This policy is attached to an IAM group that your teammate Paulo is assigned to, which is step 7 right here to reveal the policy from the AWS account 1. Finally, then you will use this policy to test Paulo's access to the dataset and his ability to modify the object's properties, which is right here, test the Paulo's access. Now, what we got to do is we access the AWS Management Console. So first thing first, we're going to start our lab, and then we're going to connect to the AWS Management Console. So what we want to do is we go straight to our task for this lab. So for task 1, what we're going to do is we're going to create a CloudFormation template and stack. So in this task, you will complete the following steps. Use the AWS CLI in the AWS Cloud 9 terminal to create a CloudFormation template. Validate the template. Use the template to create a CloudFormation stack and the associated resources. Verify that the stack was deployed and an S3 bucket was created. We're going to delete the stack and its associated resources to confirm that you can create infrastructure and remove it when you no longer need it. So first thing first, what we're going to do is we're going to navigate to the AWS Cloud 9 Integrated Development Environment IDE. So in the AWS Management Console, we're going to go to search box next to service and search for Cloud 9. To open the AWS Cloud 9 console. So I was going to switch tab and go to our Amazon service page. So I'm going to go to search bar and type in Cloud 9, and I'm going to click in Cloud 9. So the next instruction is AWS Cloud9 environment is listed. So for the environment name Cloud9's instance, we're going to open the IDE. So let's see, Cloud9 instance right here. For the Cloud9 instance, now we're going to just open the IDE. We'll open it here. So it's probably going to take a moment to load this. And then it's going to a new browser tab opens and display the AWS Cloud9 IDE. Now what we want to do is we're going to create a new CloudFormation template. So go back in here, click close that. So next what I'm going to do is in the AWS Cloud IDE, I'm going to choose files and go to the new file. So right here, this is file, and then I'm going to go to new file. So in new file, say the empty file as create .bucket.yaml. We want to keep it open, but we want to save. Go to file and go to save, and for the file name, I'm going to change it to create.bucket.yaml file, and I'm going to save it and keep it open as they instructed. But keep it open and then copy and paste the following code into the file. So I'm going to copy this code right here and paste it into our file. Okay. Now let's see the next step. So copy and paste that into the file. The next one is to save the change to the template file. So go back, save it. Now it's saved. Next step is to examine the template. So this CloudFormation template does the following. It's going to create an S3 bucket. It's block public access to the bucket. For more information, see the block public access to your Amazon S3 storage here. Enable the versioning for the bucket, and we can look at more into this if we like to. And enable server-side encryption for the bucket. As you can see, if you want to learn how to do this, you can just go to Google and look this up on the AWS documentations. So next what we're going to do is we're going to validate the CloudFormation template to and then run the following command in the terminal tab in the AWS Cloud IDE. So what to do is I'm going to copy this command right here and go into the terminal tab right here and run this code and see what happens. So it's give back an object with parameter and description. Let's see. So we receive the same thing. So note, if you receive an error, your template might have a syntax issues, but in this case, we do not have an error. So we're going to continue to the next step. And now you're going to create a new CloudFormation stack from the template. A stack implement and manage the group of resources that are outlined in your template. You can manage the state and dependencies of those resources together. Think of a CloudFormation template as a blueprint, and the stack is the actual instance of the template that creates the resources. Now we're going to create the stack by run the following command. I'm going to copy the command, and inside this terminal, I'm going to paste and run it. And it's going to return us an object with the key stack ID and this value right here. Let's go back to the instruction. That is correct. So the result include a CloudFormation Amazon resources name, ARN, and looks similar to the following. This outputs indicate that your stack was created. So what we have is created the include the Amazon resources name, ARN, right here. And so there's some note here. So the CloudFormation create stack command create the stack and deploy it. If validation passes and conflicts don't occur, and that would result in a rollback, you can proceed. You can also check the deployment status in the CloudFormation console on the stacks page. If you get an error and the stack fails to create the resources, CloudFormation will roll back the stack to troubleshoot it. Check your templates for YAML syntax error. Since we don't have any error, we're going to move on to the next step. The next step is to verify that the stack created the necessary resources by running the following command. I'm going to copy that and paste the command in here. And so we receive this object. Let's go back. So yes, the output is similar to the following. We have the bucket. We have object that contain the bucket and owner. Awesome. So congratulations, you learned how to use a CloudFormation template to create an S2 bucket. With the template, you can quickly create and deploy an S2 bucket when needed, and you can change parameters as needed. Now you will delete the bucket by deleting the stack. So some important note here: because of the lab security restrictions, the majority of this lab, you will use a bucket that was created when you start the lab. First, you will delete the bucket and that you created by using the CloudFormation template. Some note here: when a stack is deleted, all resources within it are deleted as well. Therefore, by deleting this stack, you will also delete the bucket that you created. So to delete the stack, we're going to run the following command right here. I'm going to copy the command and paste it in the terminal. First of all, I need to exit this. How to exit this? Okay, so just type in so just type keyboard and it's automatically get out of that object. So I'm going to paste the command in here and run it. Okay, so it doesn't show anything. Let me go back to our instructions. So I'm run the following command already. So step 2 is confirm that the stack and its resources are deleted. So return to the tab that is open to the AWS Managed Consoles. In the search box next to service, search for CloudFormation. So I go back and I go back to this and go to CloudFormation, click on CloudFormation, and I want to navigate in the navigate pane, choose the stack, navigate pane, choose the stack right here. We have the stack right here. Notice that's the stack that you created, which was named ADE. My bucket is not included in the list of active stack. You can also use the following command in the AWS Cloud9 terminal to confirm that the class stack was deleted. So let's see. Let's see. So the stack that we created was like ADE my bucket. So I don't see IDE my bucket in here. So just want to clarify again, I would use this command to make sure that the stack was deleted using the AWS Cloud9 terminal. So they say the output provide information for multiple stacks, but the stack that you created has a status of deleted complete. The other stack were used to build your lab environment. So I'm going to go back to our Cloud9 terminal and go to, check this command right here. Let me go and see. So this stack ID right here. This is the one that we intend to delete. So it say right here the stack status delete completed, which is correct. Awesome. And the other one is create complete the other two stack that we actually need to complete this lab. So let's go back. And then we're going to return the AWS Cloud9 terminal to verify that the bucket that the stack was created was deleted. We're going to run the following command. I believe that the one that we just did. Let's run this. It's a different command. So the output is similar to the following. It lists a bucket, but it isn't the bucket that the stack was created and was named ADE bucket. Let's see. Okay, so I'm going to go back to this terminal right here. Okay, so to quit out of the command, I was pressing the key Q, and it's automatically out of the stack above. So I go to paste the command, new command in here, and see. So we have the bucket name right here, created. Yeah, and yes, is the same things or similar as it is right here. So it is working. Now the task one summary. So in this first task, you use the AWS CLI in the AWS Cloud9 terminal to create a CloudFormation template. You validated the template and used it to create a stack. The stack created a private, encrypted, and version controlled S3 bucket. You confirm that the bucket was created, and then you deleted the bucket by deleting the CloudFormation stack. Now you have a better understanding of how the data science team can use CloudFormation to create infrastructure quickly. Now go to task 2, uploading the sample data to an S3 bucket. In this task, you will upload a sample dataset to an S3 bucket. For this bucket was created for you when you started the lab. Now we're going to examine the data in the sample dataset, which has been provided as a .csv file. So to download the file, running the follow command in the AWS Cloud9 terminal. So I will copy this command and go into our Cloud9 environment terminal, paste it in, and it is completed download. That's very fast. The code.zip files download to your local directory in AWS Cloud9. So to unzip the file, run the following command: unzip code zip. I will copy this command, go to our terminal, paste it in here. So let's see. To unzip the file, run the following command, and when prompted to replace code.zip, enter n and press enter. Okay. So by choosing no, you keep the original .zip file and create a file called lab1.csv in the current folder. Okay, so what I'm going to do is I'm going to enter n and press enter. N and enter. Okay, go back to the instructions. So to view the content, the lab1.csv file, run the following command: cat space lab1.csv. I'm going to paste the command in here. And so here we have customer ID, first name, last name. We have this data right here. Let's go back to the instructions. Awesome. So the following are the contents of the file: customer ID, first name, last name, John, date, street, address, city, state, and phone, all in here with 4 different people. So notice that the first row of the dataset contains the column name. I see. Next, we're going to copy the data into our S3 bucket. To retrieve the lab bucket name, run the following command. I'll go back in here, paste our command and run it. So we receive our buckets that include buckets and owner information. Go back. The bucket name has the format ADE S3 lab bucket. ADS S3 lab bucket. Yes. Now we're going to copy the bucket name to a temporary text file. You copy the bucket name into a temporary text file, and you will need this bucket name for other step later in this lab. So copy the dataset into the S3 bucket, run the following command: replace the lab bucket name with the lab bucket name from the text file. So what I'm going to do is I'm going to copy this, save it into my file, and then I'm going to copy this name right here, and I'm going to replace the actual name to the lab bucket name. So the output is similar to the following right here. Let me go back. So this is our name, and what they're looking for is replace the lab bucket name. So the output is similar to the following. So now I'm going to paste the command and run it. So output upload of this lab1.csv to s3 bucket name / lab1.csv. Okay, so it's look like it's working. To confirm that the file was added to the bucket, run the following command: replace the lab bucket name with the name of the bucket that you upload to the file. Okay, let's confirm it. I'm going to paste this. I'm going to paste this command and replace it with the actual bucket name and run it, and to see if this outputs something similar like this. Now go back. I'm going to paste the command in, run it. So it is correct. So today, day, time, and the lab name. Awesome. Now task 2 summary. In this task, you downloaded and unzip a sample dataset file. You examine the data and then use an AWS CLI command to copy the file to an S3 bucket. So later in this course, you will learn about the advantages of storing dataset in the Amazon S3 and how you can use the service as the foundation for the data lake. Therefore, it's important to understand how to use Amazon S3, including how to upload and retrieve your data. Now go to task 3. We're going to query the data. Now you have the ability to set up your infrastructure, an S3 bucket, by using a repeatable process with CloudFormation. You can also add data to an existing bucket. You have the basis of your POC to share with the team. However, you still need a way to query the data that you just added to the bucket. In this task, you will use S3 select to query the data set. So use S3 select to query a SQL query on the uploaded data. Now we're going to return the tab that is open to the AWS Management Console. You go to the search box next to service, and we go to search for S3 simple storage service. Okay, we go search S3. This is S3 simple storage service from Amazon. Awesome. Then what we're going to do is, in the bucket list, choose the link for the bucket name ADE S3 lab bucket. Awesome. So I click into this bucket, and here we have one file right here. So choose the lab1.csv link. Okay. Awesome. Okay. So this is our file from this bucket. Now what we're going to do is we're going to choose object actions and then go to query with S3 select object actions. So this is object actions, and then what we need to do, object actions, then go to query with S3 select object query, then we're going to query with S3 select right here. Awesome. So in the input setting section, configure the following. In format, keep the CSV selected. Format CSV. CSV delimiter, keep the comma selected. CSV delimiter, keep the comma selected. We're going to select exclude the first line of CSV data. Exclude the first line of CSV data. Okay, right here, exclude the first line of CSV data. Then compression, we don't keep none selected because the lab1.csv is not compressed. Okay, compression is none. Cool. In the output setting section, keep the default value of CSV and comma. Output setting, so keep the default value. Keep the default value of CSV and comma. CSV and comma, okay. In the SQL query section, use the existing query, which is the following. Existing query. Okay, so it's just a query select all from these S3 objects, limited to 5. Okay. So this query will return the columns from the first 5 records of dataset. Now we're going to choose run SQL query. The following result display in the query result section on the raw tab. So we're going to run the SQL query. Right here, run SQL query. Successful, and this is what we receive in the raw output. So in the raw tabs, we receive this, and it's working. Now, this is the data that you uploaded, but without the header row. By default, you see the result as raw data in CSV format. To see the data in tabular format, row and columns, choose the formatted tab. Okay, formatted, and here it is. Awesome. It's working. Now adjust the query to see only the first names for the first 3 rows. So in the SQL query section, change the query text to the following. So we only select the table with first name from the objects and limit to 3 rows only. Let's see. Go back here. We select the first name from this S3 objects table as limit to 3 only. So run the updated query. To successfully run this query, you must select the exclude the first line of CSV data in the input sections. The following results should display this. So in the input section, put exclude the first line of CSV data. Input sections. This output input sections. Yep, exclude already. Let's run it. See. Okay, so it's returned all the first name on the first name of the first 3 item. Now that you have completed these steps, you can share your finding with the team. So task 3 summary. In this task, you use the S3 select feature to query data. With this experience, you will be able to quickly discover and query data that is hosted in S3 bucket. This is one more tool that you can use for your analytic use cases. Now task 4. For task 4, we are going to modify an object encryption properties and storage type. The data science team often work with sensitive data and uses encryption to protect data. Therefore, you want to be able to show the team how to encrypt data in Amazon S3. As you learn when you created the bucket, you can include parameters in a CloudFormation template to encrypt a bucket. But you can also use the AWS Management Console to set individual object properties such as encryption, address, and storage class type. Amazon S3 supports server-side encryption with Amazon S3 Managed Keys, known as SSE S3, or AWS Key Management Service, AWS KMS keys, which is known as SSE KMS. With server-side encryption, each object has a unique key. Alright, so the keys are also encrypted with a key, which AWS rotates regularly. If you choose to use AWS KMS key, your object will also encrypt it with unique keys, but you will manage those keys yourself. Amazon S3 now applies the server-side encryption with Amazon S3 Managed Key SSE S3 as the base level of encryption for every bucket in Amazon S3. Starting January 5 of 2023, all new objects uploaded to Amazon S3 are automatically encrypted at no additional cost and with no impact on performance. SSE S3, which used 256-bit advanced encryption standard AES 256, is automatically applied to all new buckets and to any existing S3 that doesn't already have default encryption configured. The automatic encryption status for S3 bucket default encryption configuration and for new objects uploads is available in AWS CloudTrail logs, S3 inventory, S3 storage length, and Amazon S3 console, and as an additional Amazon S3 API response header in the AWS Command Line Interface, AWS CLI, and the AWS SDKs. Now, what we want to do is we're going to modify the storage class for the object that is stored in Amazon S3. We're going to choose object actions and edit a storage class. So we need to modify the storage class for the objects that is stored in the Amazon Simple Storage Service. So let me go back to Amazon website. So what we need to do is modify the object encryption. We go to choose object actions. So modify the storage class for the object that is stored in Amazon S3. You're going to choose the object actions. Object actions. Let's see. Which service is this? Modifying S3. So let's go. I want to go back to the search bar. Go to S3. Let me open a new tab actually, and go to S3. Let's see. Go to the object actions. Object actions. Where is it? Storage length, object length group, object actions. Where is it? Let's see. It's at the book. Let's go back and see. So modify the storage class for the object that is stored in Amazon S3. Modify the storage class. Modify the storage class. Where is it? Let's go here. A storage class. Storage to the storage length. Let's change storage class. Provision, management, access point. In the storage classes and intelligent terrain, edit the storage class. Object actions. Where let me Google this. So how to find object action in Amazon S3. How to find object actions in Amazon S3. Okay. Object action. storage lens group. This one, object actions. Setting, no, bucket, shower bucket, bucket, view storage lens dashboard. Object actions. You learn how to create buckets. You can include the parameter in the cloud buckets. So modify the storage class. Let me Google this. How to do this. The instruction is not very clear. So to change the storage class after you upload an object, choose the storage class. So sign in, and in the bucket list, choose the name of the bucket that contains the object. Just in here. So go to S3, go to bucket, and choose the name of the bucket. In the list, choose the name of the bucket that contains the objects list. In the object list, choose the name of the object you want to view the properties for. Bucket, this is the object. Alright, yeah, this is an object right here. This is our object. And then, okay, this is object options right here. Awesome, found it. So in object actions, go to edit storage class. This is object actions of this object inside the bucket. So we need to go to edit storage class. Edit storage class right here. Awesome. And then in the storage class section, we'll choose intelligent tiering right here. So designed for intelligent tiering is designed for data with changes or unknown access pattern. They have like at least 3 availability zone. Monitoring the auto tiering fee. So per objects fees apply for objects that are greater than or equal to 128 kilobyte. See. So at the bottom of the page, choose save changes. At the bottom, we want to save changes. Awesome. All right. A banner indicates that you successfully edited the storage class. For more information about the storage class, see here. So you can always go to documentation to read more about the intelligent tiering. But so now choose close. Awesome. So task 4 summary. In this task, you learn how to encrypt and modify the storage class for data that is stored as an object in Amazon S3. By using server-side encryption, you enhance the security of your data when it's stored in Amazon S3 when it's at rest. By using the intelligent tiering storage class, you ensure that costs are optimized for all data that is stored within the S3 object. Note that you could set both of these options at the bucket level if you want all objects in a bucket to follow the same strategy. Now go to task 5. Task 5, compression and querying the data set. So for data analytics scenarios, you should generally compress files when you store them in Amazon S3. S3 Select only works for objects that are compressed with gzip or bzip2. The steps to upload a compressed files are essentially the same as those to upload an uncompressed file. In this task, you will use the gzip format to compress the data file and compare its size to the file that was compressed with zip. Then you will upload the gzip file to the S3 bucket and confirm whether you can use the S3 Select to query the compressed file. So first we're going to compress the file. We're going to return the AWS Cloud 9 terminal to compress the lab1.csv file with the zip format. We're going to use the following command. Now go back to our Cloud 9 instance and we go to type this command in zip lab, our lab1.csv, and let's see. Then to compress the file with the gzip format, we're going to run the following command. So now we're going to compress with the gzip format. Our command is going to be gzip -v. So we go to type in this command gzip space -v. Our file is going to be lab1.csv. Enter, and now lab.csv is replaced with the lab1.csv.gz file. Compress it. To list the object in the directory, we're going to run the following command. Okay, so we're going to list everything. Awesome. So we have all the files in here, including the compressed file .gz and .zip. The output is similar to the following. Notice the size of both compressed files. The gzip version's lab.csv.gz is smaller than the zip version of lab.zip. The smaller size will reduce the cost to store the file in the Amazon S3. Awesome. Let's see. Yep, it's look similar. It's working. 2.28. Awesome. So to upload the gzip version of the dataset to the S3 bucket, run the following command. We will replace the lab bucket name with the name of the bucket that you upload to upload the object earlier. Awesome. So I'm going to copy this to my file, and I'm going to use the bucket name. The bucket name that we have earlier, which is right here. That's our bucket name. Go back, replace it with my bucket name, and then we're going to run this command. Let's see. We're going to run this command. Awesome. So we upload it. So note that the command includes the --cast-control parameter. This parameter specifies the caching behavior of the object along the request and reply chain. The output is similar to the following. If your output is different, check your command syntax and try it again. Let's see. So upload as lab1 to S3, our bucket name, and lab1.csv.gz. Awesome. So it's working. Now we need to confirm whether you can use S3 select to query the compressed file. Return to the tab that is open to the Amazon S3 console. In the breadcrumb at the top of the page, choose the bucket name. Choose the lab.csv.gz link. So return to the tab that is open to the Amazon S3 console. Amazon S3 console. Okay. Confirm whether you can use S3 select to query the compressed file. Return to the tab that is open to the Amazon S3 console. In the breadcrumb at the top of the page, choose the bucket name. Choose the lab.csv.gz link. AWS S3 console. AWS S3 console. Is this one? AWS S3 console. Wait, yeah. So choose the lab.csv.tz link. Let's go to bucket. Go here. Okay. Okay. Oh, I see it. So we are going to S3. All right. Go to our bucket, and inside our bucket we have our objects right here. This one, and we'll choose this file lab1.csv.tz. Similarly, we're going to choose our object actions and go to query with S3 select. Object actions and query with S3 select. So the input settings section keep most of the default setting. However, for compression, choose gzip. Compression, we use gzip. Okay. In the query section, in the SQL query sections, we're going to run the following query. So the query sections, what we're going to do is we're going to run the following query right here. So what it's do is we'll select everything from the S3 objects limited to 3 column. The result should indicate that you can query a compressed file in the same way that you query an uncompressed file. So I'm going to run this. And here you go. It's going to so the first 3 line, the first 3 column. Let's see. What I'm going to do is I'm going to exclude the first line of data, so it's not going to include the title of each table column. So I'm going to exclude the first line of CSV data. Run it again, so it should only return the actual data. Okay, awesome. But in this lab, it doesn't tell us to do that, so I'm going to keep everything back to where it was. Now go back. The results should indicate that you can query the compressed file in the same way that you can query an uncompressed file. So, task file summary. In this task, you learn how to compress a data file with gzip compression. Gzip is more efficient than zip to reduce the overall size of a file, which can be helpful to reduce storage costs with Amazon S3. One factor in your cost is the number of gigabytes of storage that you use. You also learn that you can use S3 select to query data even when it is compressed. This demonstrates that you compress data to save on storage cost without losing the ability to query that data. Now go to task 6, which is managing and testing restricted access for a team member. When the data science team uses the workflow that you have created, the team members should only be allowed to access certain AWS service and features, such as S3 select to create data sets. This is for similar to the let's demonstrate the list privilege, the principle of list privilege. List privilege, where because we don't want our user or our coworker to have access more than what they need to do their jobs to protect our data for security purposes. And so they have an example right here. So one of your teammates, Paolo, will need permission to access the Amazon S3 and use S3 select in the console or through the command line. However, he should not have permission to modify the CloudFormation template that is used to create the bucket. So in this task, you will review the data science team IAM group and associated IAM policy. You will act as Paolo to test a few actions to determine whether the group and policy have permission to access the data set in Amazon S3. Important note here is for the lab security purposes, you cannot create IAM principles or policies. Therefore, the IAM group and policies for the data science team and an IAM user for Paolo have been created for you. In this task, you will examine the group and policy in the IAM console. And noted that you could also go to the CloudFormation console and review the template that was used to create these IAM resources. So we're going to review the data science group, IAM group, data science group, IAM group, and the IAM policy that attaches to the group. So going to the search box and going to next to the service, we're going to search for IAM. Okay. I'm going to go to IAM. Let's go open a new tab. And this one, I'm going to choose IAM. Go in here, access management. Let me go to back to an instruction. So in the navigation pane, choose user. We only have one user right here. We just choose user with is Paolo. Notice the Paolo user listed here, and that he is part of the data science group IAM group. So we're going to choose the data science group link. Data science group link. Let's go back. This is a user. Data science group link. Where is it? Data science group link. User group. Okay, it's right here. Data science group link. Let's go back. So inside the data groups science group link already. So on the data science group detail page, choose permission tab. Permission. The name of the policy that is assigned to this group is display. The name of the policy for this one is display. So policy for data scientists right here. Choose the policy for data science link. Okay. So we have one right here. We have services, which is S3, simple storage service from AWS. Access level is limited. So limited the permissions, management, tagging, and write. Okay. So it can manage, it can tag, it can write. So this is its permissions for the S3. Let's see. Resources multiple, request condition none. So the detail page for the policy display reveal the permissions that are associated with the policy. Notice that the permissions are limited and only provide access to Amazon S3 and the ability to perform specific actions in the Amazon S3. So we can see that Paul can only have access to S3 and his permissions are limited, including only management, tagging, and write. Okay. Now determine whether Paolo can access the data in Amazon S3. To test his access, you will issue AWS CLI Command Line Interface commands using his credentials. First, you need to retrieve his access ID and secret access key along with the AWS regions for the lab account. So in the search box next to service, we want to choose CloudFormation. We go to a new tab. Let's search CloudFormation, and in here we have inside CloudFormation. Navigate to the pane and choose stacks. Awesome. We have two stacks. Choose the link for the stack name where the description contain ADE. Contain ADE description. Where is it? ADE. Actually, I don't see ADE. Which one contain ADE? Oh, right here, ADE description 1.0. Awesome. All right. So on the stack detail page, choose output tab. Right here. Awesome. We have bucket name, Paolo access key, and Paolo secret key, access key. Awesome. So note that when you create a CloudFormation template, you can choose to output information about the resources that the template will create. The CloudFormation template that created the resources in your lab environment output the access key and secret access key for Palo user. So copy both value to a bus variable using the following step. So from the output tab, copy Palo access key value to your clipboard. So we're going to copy Palo access key right here, copy it, go back, return to the AWS Cloud 9 terminal right here. And to access the variable for the access key, run the following command: replace access key with the value from your clipboard. So AK equal to the access key. AK equal to the access key and run it. Awesome. Return to CloudFormation console and copy Palo secret access key. Palo secret access key is right here. We're going to copy it. And then what we're going to do is we will return to AWS Cloud Terminal again, and then we're going to create a variable for the secret access key. Run the following command and replace the secret access key with the value from your keyboard. So SAK stand for the secret access key. SAK. So SAK secret access key assigns to that Palo secret access key. To test whether Palo, the user can perform certain AWS CLI commands, you can pass the user credentials as bus variable, AK and SAK with the command. The API will then try to perform that command as the specified user. You will do this in the next step to test whether Palo user can run an AWS CLI command for the Amazon Elastic Compute Cloud. Amazon's EC2 service, run the following command. Okay, so to test whether Palo user can run the AWS CLI command for the Amazon Elastic Compute Cloud EC2 service, we have to run this command right here. Let's go do that. Run the command. Error occur. So the following error message display which is expected. Recall that IAM policy that is attached to the IAM group that this user is in does not have the permission for the Amazon EC2. So the error occur. Let's go back to see our error. So error occur unauthorized operation when calling the described instance operation. You are not authorized to perform this operation. User IAM here Palo is not authorized to perform EC2 instance because no identity-based policies allow for this description instance action. Okay. So test whether Palo user can run the AWS CLI command on the S3 object. So what we're going to do is we're going to run the follow command and replace the lab bucket name with the appropriate value. I'm going to copy that into my value, and I want to replace the lab bucket name. For the lab bucket name, where is it? So the lab bucket name is this one right here. I'm going to go back and replace the lab bucket name with actual bucket name. I copy the entire command, and then I'm going to paste the command here. And so we have this object right here: accepted range byte last modified, content length. Let's go back. So the output is similar to the following right here with accepted range, last modified, content length, etag, content type, server-side encryption, metadata, and storage class. So to view the content of the S3 objects, run the following command right here. So we want to run this command: cat pull lab.csv. So we have the entire table and for value column value right here. Note that As an alternative to running the AWS S3 API get object command and printing the content of the object in the terminal, you could also use the AWS S3 API select object content command for more information. We can read more about it in the AWS CLI command reference. So, task 6 summary. In this task, you learn how to review permission in the IAM console. When you manage access control, a best practice is to assign IAM user to IAM group and then assign a policy to the group to define permissions. Understanding how IAM authenticate and authorize user is important when using data pipelines for your data in AWS. You want to ensure that only the people who have a critical need are able to access and modify the data. In the task, you also learn how to use AWS CLI command within the AWS Cloud9 terminal to test a user permissions. Finally, you log into the console as a specific user to further test the user's permissions. With these skills, you will be able to ensure the most appropriate and secure data access strategy for you and your AWS users. Updates from the team. So Sophia and data science team are happy with the workflow that you created by using the CloudFormation and S3 Select. By using this workflow, the team can use AWS services in a way that follows best practices and simplifies their workload. Okay, so that's pretty much it for this walkthrough for this lab. I hope it is helpful. Thank you so much for watching and have a good day.